STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Dr. Georgia Donolfo.
Hello, and welcome to this week's NASA STEM Stars. Each week, we connect with subject matter experts that work at NASA, and we learn about their STEM career and their education and personal interests. At the end of today's episode, I will also challenge you to complete your own mission and share your work with us. I'm Jen Hudgens, and I'm coming to you from NASA's Kennedy Space Center in Florida. Today's mission plan will be to meet our guest and explore her career. I want to encourage you to ask your questions in the chat box to be answered by our guest. So let's get started. Today's guest is Dr. Georgia Donolfo, and she comes to us from Goddard Space Flight Center in Maryland. Welcome, Dr. Donolfo. Thanks for joining us today.
Well, thank you, Jen. Thanks for having me on the NASA STEM Stars. Excited to sort of share what I do. So yes, I'm coming from NASA Goddard Space Flight Center, and I've actually been here for over 20 years. I started in astrophysics, but in the last 10 years or so, I've been working in the field of heliophysics, and hopefully we'll get into what the differences are between those two fields. I'm a mom of two teenagers. My daughter graduated from high school last year in a pandemic, so that was an experience to get her through that. I have a big international family. My husband's from England, so we are very lucky to be able to do a lot of traveling. I've got a half brother and half sister from Samoa, and a brother who's an opera singer. So
Wow.
Because we have such an international family, we like to do a lot of traveling. So
is that part of you travel a lot? What other things do you do as a family?
So we do like to hike a lot. It's been really great that we're interested in hiking during the pandemic because there's not much else to do. My son is in Boy Scouts, so the big thing right now is that we're training to do a backpacking trip that's about 10 miles a day in New Mexico this summer called Philmont. And I'm scared and excited because it's a lot of backpacking. So we're doing a lot of training for that.
Do you get to go with him, or is he going to go alone with his troop?
No, I'm signed up to go. We'll see if I can do it.
That's awesome.
Yeah, it should be fun.
Yeah, my sons are in Scouts too, so I'm very familiar with the Philmont trip. So congratulations to him for that.
Yes, yeah.
So
it's great.
I was going to say, there's some pictures of you and your children and husband on the screen now. Can you tell us a little bit about the pictures that we're looking at here?
Well, sure. It's just kind of a mixture of, my family. So there's proof that I have an English husband. He's standing next to one of those old-fashioned telephone booths that they don't use in England anymore. We've done a lot of traveling, especially to England and to Italy, which is where my family background is from. And you can see my big Samoan clan down at the bottom here. Just a big family and a lot of hiking trips. And then finally, I think the thing that's probably the most exciting of these pictures is that I took my family to see the 2017 solar eclipse in Oregon. So this is us just standing, waiting for the solar eclipse to happen. And I think there were tens of thousands of people in a county fairground that spent the night, and we were among them in a tent. The one thing I want to say is we could see that shadow cross the earth, and my little son just screamed in glee. And at first I thought, oh my gosh, what is everybody going to think? But everybody did. Everybody screamed when they saw this shadow race across the whole horizon. And it was wonderful to have like tens of thousands of people experiencing that together, all different kinds of people. Just a super experience for everybody.
I really agree. I was fortunate enough to watch it myself. I hope the students that are watching too got to see and experience that, because just experiencing the drop in temperature,
Yeah.
during the eclipse, and then you hearing the bugs come out and chirping away, and it's a bizarre experience that I hope everybody gets a chance
Yeah,
to
me
see.
too.
So you mentioned that you're an astrophysicist and that you are working in the heliophysics department. That's a lot of big words. Can you share with us your education background and exactly what it is that astrophysics is and heliophysics is for our students that are watching? And I want to encourage students to drop your questions in the chat box as Dr. Donalfo is talking as well. Yeah.
Well, sure. So I started in astrophysics, so that's probably a good place to begin. But, astrophysics is really the study of everything, almost everything outside of our solar system, if you will. So, all the galaxies and black hole at the center of our own galaxy. My particular focus was on looking at very fast moving particles, almost fractions of the speed of light, that rain down on the Earth, but they're created when a star dies and goes supernova. So those are called galactic cosmic rays, and I think we'll get into talking a little bit more about that, because they are kind of the prevalent source of radiation hazards for astronauts when traveling in space. And then, as about 10 years ago, I switched from looking at the big accelerators like the death of a star to our more local accelerator, which is our sun. And so the study of our sun and the heliosphere, which is the giant bubble that protects our solar system from the interstellar medium, that heliosphere, that is called heliophysics. And so that's really where I transitioned from kind of the big picture to a smaller, more local accelerator in our solar system environment.
So tell me, when you were in high school, did you say to yourself, I'm going to study the sun someday and I'm going to learn about cosmic rays? Or how did you get interested in that? What sparked your interest way back when you were in high school?
So, I've been interested in science all along, and I hadn't really realized that my mom had saved all these awards for me that I had completely forgotten about. But I tell you what was most pivotal for me, I was just really lucky because I took physics as a junior in high school, and all the seniors, I was the only junior, and all the seniors graduated, and I got 1 month with the professor by himself while I was in high school. And it was a huge learning experience for me because I asked every question I ever wanted to ask because it was just me and him. And so, I learned, one, how important it is to ask those questions, but two, just how exciting the field was. And I think that's what changed me. Believe it or not, I wanted to be a writer before that. And so it was that class that sort of sent me on the mission to do space physics.
And then where did you choose to go to for your bachelor's?
So I started at Wellesley College. I don't even have that on the current slides here, but I started at a women's college for the first year. And then I really wanted to do more research. So I transferred to the University of Chicago. And so there's a picture of me in front of a very famous Henry Moore statue called Nuclear, I think this is Nuclear, well, it's about the nuclear, fission. So it's the very first sustained nuclear reaction that happened at the University of Chicago. And that's where I got my bachelor's. And then I went to Washington University in St. Louis to do my PhD. Is another very exciting university in terms of the kinds of space sciences that are going on there. Then finally, I went on to do a postdoc at California Institute of Technology. And so there's a picture of me there. You can see this kind of classic arches in the main atrium part of Caltech, which is very beautiful there. And then I'm just sitting I'm holding a piece of really cool material called aerogel, which we flew on one of our missions. Mm-hmm. And then I ended up with my first postdoc, second postdoc at NASA Goddard Space Flight Center. And I've been there ever since.
So you went for an internship after you finished your education. Is that what? Is that what you're
Yeah, so
saying?
typically what you do, they call it a postdoctoral fellow. So you kind of do it's like a transition from your graduate degree to a postdoctoral fellow, which is a transition until you get to your more career-oriented position. And so I did two of those. One was it was at Caltech right out of graduate school, and then the second was at Goddard Space Flight Center. And then once I finished that position, then I applied for a regular staff position at Goddard.
Wow, I bet you're happy that you went into that field instead of writing.
Well, the irony of that is that, you might think that we're doing only science as a scientist, but actually there's an enormous amount of writing that you have to do in my field. And so I think I kind of got both, which is great.
So we've had a student ask a question about which books and online study material would you suggest if they were interested in astrophysics? So do you have any favorite books out there that you refer to when you are doing some research?
That's a tough question. I mean, I think that would date me to tell you which are my favorite books, but and it depends on the field that you're looking at, in terms of if you wanted to do plain physics, certainly you're going to look at this very classic textbook called Jackson, and it is a good book. But I think some of the books that I've used, they're probably more recent versions of those. And then there are some wonderful books that just talk about, science. I think even going back to the first 3 minutes by Weinberg, maybe, and Stephen Hawking has some really fantastic
Oh yeah.
books about science. So, yep.
All right, those are good reference books for them for sure. And then one other one, going back to your interests, do you use telescopes personally at home, or is there something you could recommend to students who are interested in looking at the stars?
Oh, so we have a very small telescope here that we built. It's kind of sort of, supposed to be what, a student can build. I cannot remember. It was years ago that we got it. But I would say that we got it simply because, and we took it out recently because, because we're stuck at home. And as it so happened, for a period, I'm not sure if it's still going on, but for a period there was Saturn, Jupiter, and Mars all up in the sky at the same time. And so I was showing my kids that. But a very, very simple telescope can work quite well. The only thing that I would say is that you need to have a tripod. Like, you're holding it, you just can't hold it still enough to really see what you want to see. So it takes a little bit of, getting the right things together if you really want to look through a telescope. But it's not what I normally do, I will say that.
No, that's great advice. That's great advice. So let's go back to talking about your early career at NASA. What are some of the projects that you worked on, maybe as an intern or as an early scientist with NASA?
Well, so these are a mixture of pictures. They're always the funnest to talk about. What can I say? This was very early in my career when I was still doing astrophysics. And so we were studying galactic cosmic rays. And again, just to remind you, when a star, sort of outspends its life, it dies in a massive explosion that we call a supernova event. And in that explosion, it kind of spews out all kinds of material at very, very high speeds. Fractions of the speed of light. And that material bounces around in our galaxy, and some of it enters into our protective heliospheric bubble and actually reaches the Earth. And so we want to know what kinds of material is that. It actually, believe it or not, fills the periodic table. The most abundant form of galactic cosmic rays is in protons and helium, but it actually fills the whole periodic table. So the way we like to measure these things is we can send up a instrument that's kind of the size of a minivan onto a high altitude balloon, which is filled with helium, and it goes 4 times the height of a plane into the sky, so 120,000 feet up. If you were to sit up there, it looked like you were in outer space. And then these galactic cosmic rays just rain through our instrument. And I like to say that we're actually measuring the speed and the mass of these particles as they pass through based on the different kinds of technologies that we're using in our instrument. So anyway, that's just what we were doing. But you can see these pictures are super fun because to launch a balloon that goes up to 120,000 feet takes a lot of equipment run by NASA. And so you can see our instrument is down in the lower left. This instrument was actually called ISOMAX. And we had it in a little kind of egg-like shaped pressure vessel that I actually drove all the way from Michigan up to the upper parts of Canada, very remote areas of Canada. And then they have this launch vehicle, which actually launches the balloon itself. Eventually, you have to pick up your instrument, so it's dropped from the balloon and falls with a parachute to the ground. And so on the very corner left there is a cute picture that I took. It's in Scientific American, actually, of the landing of our payload. And then we actually track it with a small plane. So this is me just going from one airport to the other, trying to track the balloon until we're able to actually have it land on the ground. So anyway, one of the most fun times, I think I've done 5 or 6 of these balloon campaigns, and they're in these remote areas. You're there for 3 months. It's really fun.
That looks exciting, and I'm sure watching your mission get launched and then getting your data back has to be very exciting for you.
It is. I mean, and we've had, everybody that's in the field where they're doing high altitude balloon flights we call them kind of like war stories, there's successes and there's deep failures that happen with them, and we've done everything from have it land and then the parachute opens back up again and drags our instrument. We've had that happen. We've actually let go of the parachute too soon and destroyed an instrument. So, but still we somehow managed to get the data that we needed to get, and it is really very gratifying when you finally get that. So
cosmic rays are continually raining down on the Earth. Is that why you're able to launch these balloons and collect that data? Because it's a continuous cycle.
It is a continuous thing. Yep. The sun is very active, and the sun, which really is creating our heliosphere from the solar wind that's coming off the sun at all times, it goes through its own cycle. And so when it's in a maximum period, it's actually harder for those cosmic rays in the interstellar medium to get in. And then when it goes into a minimum part of its cycle, it's easier. But they still do penetrate all the time. It's just that they kind of oscillate back and forth between being a lot and a little on the same cycle as the solar, the sun is cycling as well, 11-year cycle.
Okay.
So yeah,
what cycle is the sun in right now?
Sorry?
I'm sorry. What cycle is the sun in right now? Is it coming out of its minimum, or?
We're heading into a solar maximum, and that's actually kind of exciting because the sun has been ridiculously quiet, and we have a couple of spacecraft out there right now, Parker Solar Probe and Solar Orbiter. So Parker Solar Probe is going, is closer than any other spacecraft to the sun, and we'll fly right through the sun's atmosphere, which is super exciting. But the sun has been very quiet. So as a scientist, we've been, just waiting. And only a few days ago, we started seeing a big event from the sun. So there are a lot of excited scientists out there, poised to do some analysis.
I'm sure you're one of them.
Oh, yeah.
So tell us, what does, now that you're doing Helios physics, can you tell us exactly what you do at NASA as far as that goes?
Yeah, sure. So, one of the things we do is sort of related to what I said earlier, that we will look at the data that's coming back from these sort of flagship missions like Parker Solar Probe. There are a lot of other missions that are still out there. We've got stereo spacecraft, which originally were 2. And looked at the sun all the way around to the backside of the sun and in 3D. So it was really a very cool, because it gave us the first backside images of the sun. And so we take that data and we analyze it to better understand the sun. The sun is very dynamic. It's got solar flares that are going off, and it's got coronal mass ejections, which just spew out huge amounts of matter at very fast speeds. When those, when that matter, which we call coronal mass ejection, reaches the Earth, it can disturb the Earth and cause, space weather. And so that's a big concern to us, that we want to understand that. So ultimately, we want to understand how the sun is, it has these energetic processes. What causes those energetic processes? And can we get better at predicting those energetic processes. So that's one thing we do. The other thing is building instruments, which is also somewhere where my heart lies, because we are putting together a bunch of different instruments right now for different spacecraft. And so right here, I'm showing one that I think is super fun for students, because it's in the middle here is our instrument inside what we're calling a CubeSat. It's a very small spacecraft that's made up of 10 by 10 by 10 centimeters chunks. And in this case, it's a 3U. So 1U is a 10 by 10 centimeter. And so ours is 3 of those. The instrument takes up 2 of them, and then the spacecraft takes up the other one. And believe it or not, the students built there's our undergraduate students that built this spacecraft for us, and we delivered our instrument to them. And we're waiting for that one to be launched. So that's a fun picture, just showing, that we are about to be launched. It's going to go in low Earth orbit and look at neutrons. So my interest is in looking at neutral particles. Then I'm showing an instrument down on the bottom here, which is made up of what we call silicon photomultipliers. They're basically tiny little light collectors. And this instrument is going to be flown on a CubeSat as well, only 6U, so twice the size of the one that we're showing in the middle picture. And that is going to look at gamma rays that are associated with gravitational waves. So that's a pretty exciting astrophysics application. So they can do both things. And then finally on the right, I'm just showing that I have students pretty much in my lab all the time, and postdocs, and it's a real highlight of my career is to be able to mentor my students.
So I had a question from a student. Are there any problems in the field of astrophysics that hasn't been solved yet?
That's a really good question. Well, we have to look at things like, how much matter, how much dark matter and dark energy are really in our universe. That's still something I think what is dark matter? I think that's a big question. Understanding gravitational waves is a whole nother science that will probably rain down a whole lot of other questions. Just being able to, because it's all of a sudden we have this new thing that we can use to probe the universe, and that we haven't been able to do before. So I suspect that there will be lots of questions asked once we start to have, that become a regular everyday measurement that we're doing. So those are, big ones. But honestly, we can't understand everything that's going on with our sun. We don't have to turn to just the universe and at large. We're still trying to understand the boundary between our heliosphere and the interstellar medium. How does that work? How do some particles get in and out? Lots and lots of questions to work on still in the field.
So we have a couple more questions kind of building on what you've just mentioned. They are curious about how heavy metals are formed if the sun can only fuse hydrogen to helium or a neutron star creating iron. So how do we get those heavier elements that you mentioned that are in the periodic table?
Yeah, so that really does happen when the star goes supernova. So when the star explodes, then it just bombards everything that the material with lots of neutrons, and you can kind of create heavier material from these more explosive type events. But you're right, by the time you get to iron, it requires more energy to make something heavier than that. So our sun will only really get, be able to produce almost up to iron. And then at that point, to fill the rest of the periodic table, we need these very eruptive events, different kinds of supernova particularly.
Perfect, thank you. We're almost out of time, and I know we have another slide to share, and we also had a question that kind of goes along with your last slide. They want to know what your favorite part of your job is. So if you want to talk about what it's like to work at NASA and some of the things that you do, you probably can roll your answer into that as well.
Sure. Yeah, I think I could actually. So, what I'm doing right now at NASA are a couple of different things. So I do make instruments, but of course, I want my instrument to fly on a mission, right? So I'm also quite involved in brainstorming missions, coming up with a mission idea that we would like to propose to NASA. And so that's just sort of what's shown on the left here are a bunch of different ideas that we've been working on. And the whole way that a mission comes to life, if you will, is pretty exciting because you go to these design labs and you have engineers, maybe 10 different engineers with different skills from orbital dynamics to, mechanical, electrical, communications, everybody coming together and saying, okay, well, that doesn't work. That's a great idea that you want to do that, but that will never work. So let's try something else. And so you kind of eventually, with all of your various expertise, come together to form a new mission. And it is really one of my favorite things to do. It's just so exciting to work with a bunch of different minds. Everybody's got something to add to the table. And in the end, you come up with this product that's super exciting. It's a new mission concept, that hopefully houses the instrument you've been building. And there's my son, who's part of, when we have these missions, we put them through environmental testing, and behind him is a giant vacuum chamber where we test our spacecraft. And so that was my son when he was a bit younger, getting an opportunity to look at that. And that's pretty fun being able to bring him there. The other thing that I do is called Project Science. So that is a mission role where we're responsible for kind of talking about the science that's involved in the mission and bringing all of the scientists together and making sure that the mission is on track with the science that we first proposed to do. And that can be very exciting and rewarding too, just to be able to follow the mission from beginning to end, be a part of the communication to the public about how the missions are doing. And so I'm currently involved in all the 3 missions that are shown there, which is Stereo and ACE and IMAP.
Well, thank you so much for sharing. I think you did. I really do. I think you did. So do you have any last minute advice for our students that are watching and may be interested in pursuing an astrophysics career or working at NASA?
Well, I think for me, the most important thing, and I'm pretty sure I started with that, was ask questions. Just ask. There's really never a dumb question. I pretty much say that to every single student that comes through my lab. The more questions you ask, the better you'll understand what you're trying to learn. And so, don't be afraid to do that. That's really one of the biggest advice. The other one is that you should take a lot of math if you want to do what I do. That would be a good thing to do. But don't be afraid. If you really like to write, there's plenty of opportunities to do that as well. So, we need more scientists. So I'm hoping I've inspired you.
Well, you've inspired me, and I'm sure the students watching are inspired as well. Thank you for sharing your time with us today. I hope you had as much fun as I did.
I did, yeah, thank you.
We actually have a fun mission that I think you'll appreciate. There is a game that I'd like students to check out. It's called Shields Up, and they will learn how to shield satellites from damaging solar energetic particles. So I think you'd appreciate that game as well. It might be fun. Go to NASA's Space Place, and we'll drop that link there in the chat box for you to click on and go check that out. And share your score with us on social media at our hashtag NextGenSTEM. We'd like to see how you're doing with that game. And then next Wednesday, we're going to meet with Dr. Hashima Hassan with the James Webb Space Telescope. She's the deputy program manager for that telescope. So I encourage you all to tune in next week on Wednesday at 1 o'clock Eastern. And we will talk to Dr. Hassan and see how we're doing with the James Webb Telescope. So again, thank you, Dr. Donolfo. I hope you had as much fun as I did, and we will see you all next time, STEM fans.